considered a difficult GMAT question, and the question states, if t is a prime number, is this expression divisible by t squared? Now let's look at these conditions right here. T squared, now if t squared is less than 25, that would preclude 5, because 5 times 5 is 25, and it has to be less than 25. So only t's that would work right here would be t equals to 2, and I'll just put comma 3 here, okay? All right, so again, t equals 2, 2 is the only even prime, 3 is a prime, but 5 wouldn't work here. So these are the only two prime numbers satisfying this condition. Now let's take a look at this condition right here. They always give you something that's going to factor usually on something like this, and this is no exception. You can write this as t minus 6 times t minus 2, I believe. And the factorization works out pretty well here. T minus 2 equals to 0. Now, of course, that implies that t would be equal to 6. Now notice right off that this is not a prime. T equals 6 is not a prime, and t is equal to 2, which is a prime. Okay, and notice that 2 is shared by both of these conditions. You have a 2 here, and you also have a 2 here. Now we can go ahead and cross this out since this is not a prime. Okay, we can eliminate this possibility. All right, now let's just take a look at what would happen here. T squared would be equal to 4. Okay, and notice this factored expression contains a 4, and I'll talk to you about that in a minute, but it contains a 4, so t squared equals 4 certainly checks. Okay, now t squared equals to, if t is equal to 3, that would give you 9 right here. Now if you'll notice right here, y'all, and I will answer this part right here if you don't see this, we have a 4 here. Now if you put a 9 right here, this would give you 37, right? I'm saying if you take this 9 and put it right here, 4 times 9 is 36, plus 1 is 37. If you put the 9, if you put the 3 right here, this part would give you 5, right? Okay, and so you see, this is not divisible. This expression, 4 times 37 times 5, cannot be divisible by 3 because the prime factor of 3 is not present right here. So we would X out this condition right here. Okay, which means we're Xing out t equals 3. All right, so you see, if condition 1 were true, this statement would be false, all right? But condition 2 works out just fine because t equals 2 works just like we saw because of the presence of 4 in this expression. So the answer, I'm not sure quite how they word these things, but this would be sufficient right here. This statement right here would be sufficient. In other words, the truth, let me come back down here. The truth of this circled expression ensures the truth of this expression right here. But it wouldn't be the case right here because 3 doesn't work, right? So this would be sufficient. I'm not quite sure how they word it, but this would be the answer. And without this one alone would imply this statement right here. Now, if you're curious about how I did the factorization here, which wasn't necessarily required, it's just a little bit easier. Notice what I did. I just took these two terms and factored out as 16t squared, right? Now notice there's an understood 1 in front of anything. I'll put a 1 dot. Okay, that sometimes is confusing, but that's where this 1 comes from right here. And of course I took a 4 out of this, I factored 4 out of these two terms. They call this factoring by grouping. That led to this common binomial factor of 2t minus 1, okay? And so that's how we get this factored expression, which is useful in determining the divisibility of this statement right here. This is a divisibility statement. But I do want to, this is the answer right here, and I think they worded this would be sufficient alone. This one is going to be sufficient all by itself. Okay. Sufficient. Hope I spelled that right. Sufficient. Yeah, that's sufficient. Okay. So there you go, folks. This is the answer, and I hope that helped. Let me know.